Good evening. So hopefully to everyone's relief, I promise not to use a laser pointer. Anyway, so as was already mentioned, I am the chair of the OpenMP Language Committee. So I'm going to give you kind of a quick update on the activities over the last year and what's coming up in the future for the Language Committee. So in the last year, we've actually released 2 technical reports. TR2 was released in March that details an OpenMP performance tools support interface. And just last week, TR3 was released. And TR3, I'm going to tell you a lot more about, but it's a current snapshot of what has already been adopted for 4.1. Then to give you, what we have on the horizon is 4.1 and 5.0. 4.1 is a minor release, so in keeping with that, it will be clarifications and errata to the existing specifications. So as Michael mentioned, just a little over a year ago, we released 4.0. We put a lot of work into making sure that the quality of the document is very high. But nonetheless, when you're talking a document, I think the 500 pages actually included the examples, which aren't actually in 4.0, so it's more like 300 pages. Still rather long, I admit, but so when you're talking a 300-page document, no matter how many times you proofread it, there's always going to be some errors that remain. We're also adding several refinements and minor extensions, and I'm going to be showing you a lot of details about that before I'm done. The basic philosophy with minor releases is that we will not break existing code, and generally we're looking to have not a huge burden on implementers in order to support a minor release beyond that required to support the major release that it advances. So up to now, I've thrown a little bit of caveats into this, but given the release of TR3, I'm now quite confident that this time next year we'll be telling you about 4.1 and that it's officially released. All right, 5.0 will be our next major release, and so it doesn't quite follow the same rules as a minor release. It will add several new major features. What those all are, we can't say for certain yet. I'll tell you what we do see coming at the end of it, later on. And unlike a minor release, we say do not break existing code unnecessarily. We don't wantonly change how things work so that your code stops working. But if we come upon a compelling reason, we might well do something that could break existing code. We didn't do anything like that in 4.0, so I'd say the probability of that is low. So for right now, we're saying that we're going to target having the 5.0 out 2 years after 4.1, and that is somewhat ambitious. In any event, we are adopting a plan to have basically a snapshot of what we're planning to add each year from now on. If we don't in that year, anyway, so we'll be releasing those each year, all right? And so if we don't get 5.0 out in 17, I would expect to get it out in 18, and in between 4.1 and 5.0, we'll have 1 or 2 TRs that capture a snapshot of what we've done. So TR3 is really something that in the past we might have called a comment draft. It was adopted last week. As Michael said, it includes 52 past tickets. So these are things that we have already firmly decided that we are going to add to the language. Now the ARB has to actually ratify whatever we put forward for 4.1, but I have never seen it happen that the ARB did not adopt what we put forward. All right, and so as a result, you can actually tell your implementers, I want stuff that's in TR3, all right, because they're pretty well assured that that's what it's going to be. We're not going to start changing how things are spelled, for instance. Michael mentioned, we've actually gone from FrameMaker to LaTeX. So this is our first released version following that conversion. And I tell you this because although we've done quite a bit of proofreading on it, when you go from one document mechanism to another, undoubtedly you can get some errors in the conversion. We had a few, we've caught many of them, hopefully all of them, but if you were to ask me to say whether I believed we caught all of them, I would say no. Anyway, so TR3 is available for download at the OpenMP site. If you go and look at openmp.org/tr3, capital T, capital R3.pdf, you'll get it. And there's also a version that shows what's actually different, and I'm not sure what the URL is for that. So one of the big things we've done in TR3, and which we promised was one of the main focuses for 4.1, is refining the device constructs that we added in 4.0. We have formally updated the spec to state that on several of the device constructs that there's an implied flush. Typically at the beginning of the region and at the end. If you look at the ones that we added it to, you would realize that things didn't work if the vendor didn't, if the implementer didn't put flushes in those places. Now it's just clear that they're required. We've added unstructured data movement, and I'll tell you more about that before I finish. We've added a thing that we call a map modifier. So map is how you move things, well, how you specify that things have to be available on the device, and how you specify that between that and the target update construct that things have to be made available that were on the device back on the host. And for that, you can have these nested, and the way the specification is written in general, if things are already present on the device, then any movement or updating the device copy or device version did not happen. All right, so it saves you overhead. But there's times where you actually want to ensure whether it's there or not that it gets updated, that the current version is moved over. And so now you can add this always modifier to your map clauses, to your map types, and say always move the current version over, always move the current version back. If you read articles written by certain people in HPC Wire, they claimed that OpenMP did not support asynchronous execution on devices. This was completely false, and I believe the author of that should have known, but we won't go into that. Basically, what you would do with 4.0 is you would start an OpenMP task, and then you would start the device construct, and that would guarantee you that you're getting asynchronous execution. To simplify things a little bit, what we're doing in 4.1 is stating that basically all of the device constructs are tasks, all right? And you might go, oh, wait a minute, isn't that going to cause problems? Well, they're a special kind of task, which we already had. They're basically undeferred included tasks, which means that you have to execute them immediately, and you can't, and they get executed on the thread that encounters them. All right? Now, so that's actually the current semantics. But now we have a no wait clause for those constructs, which says if that no wait clause is present, then it's not an undeferred included task. It's a task that you can go and spin off and put on a task queue and execute later. So now you have a clear way to to support asynchronous execution. It gives you a little bit shorter syntax on it, and it also potentially, by having the two mechanisms combined, offers some potential opportunities for optimization. There's many other things that we've done in there. I'm not going to go into them all. Look at the diff file if you're interested in finding every last difference. So The unstructured data movement is a pretty significant change. So previously you always had to, whether you were using the target data region, so a data region, or a target region, you had to have a structured block following it. So in order to say, I want this variable available on the device, you actually had to be able to enclose, somehow identify statically a region of code in which that variable was made available, right? Which often is cumbersome and sometimes just not really possible, and at least it would enforce some bad software engineering practices. So we've added unstructured data movement and made some changes to how things are phrased. The basics are that previously you would have a target data region, and it's still there, all right? And at the beginning of it, you would have the ability to say, make this available on the device, and at the end of it, you could make it unavailable, all right? You basically no longer have that over there. So the equivalent is now you have a target enter data region which says, go and make this available over there, and that takes a variety of clauses, but in particular, for the map clause, the only map types that are allowed are to and alloc, which says, move it over there, and if it's not there, put the data over there as well, and make it available over there, but do not copy it over. All right, and then target exit data that says, okay, it doesn't need to be there anymore, and then you get from, which says bring it back. You have release, which says, if it's the last time I told you to put it over there, deallocate it, and delete, which I think is a bad idea, but I'm told that people want it, which is basically no matter how many times I've moved it over there, take it off. All right, and so it's actually deallocated because you could have multiple nested regions, right? You could basically have moved it over several times, and normally you would expect to have matching times to remove it. All right, and so we've rewritten things so that they're now in terms of reference counts, and we also rephrased how the existing constructs that did mapping, how they work to use the reference counts, and basically that they combine the enter and exit semantics. All right, so we have done a number of things for the device constructs, but it's not all we've done. One of the most significant things we've done is made some changes to how the ordered construct works. And in order to do that for the ordered clause on the loop construct, we've added the ability to have parameters on it, all right? And in particular, you can now specify a integer parameter that says the ordered construct is going to be applied to some number of nested loops, sort of like collapse, but a little bit different. And in particular, what that says is now, the idea is to be able to apply OpenMP to do across loops, all right, which are essentially wavefront loops. All right, and so now, there's parallel. So, the ordered construct. Previously, you say, do not execute this iteration until all previous iterations have been executed. So at least at that part of the loop body, you're essentially eliminating all parallelism. So it's a pretty heavyweight thing, but it does allow you to apply OpenMP to loops that have loop carry dependencies. All right. So with the do across one, you now have multiple loops, and you actually have more parallelism there. If you think about it, you're saying iteration 0, 1 is dependent on loop iteration 0, 0, and iteration 1, 0 is dependent on iteration 0, 0, and basically just sweeping through the iteration space like that. All right, but those two iterations could execute concurrently, and if you use the collapse clause and the ordered construct, you would not allow them to execute concurrently. All right? You could manually rewrite your loop and do something called loop skewing so you could get at that parallelism, but that's a very nasty and mechanical transformation, which is actually fairly easy for the compiler to do. And so that's what this allows you to do. Basically specify, do not execute this ijk, however many levels of nesting you have, this iteration until the ijk, one that I'm dependent on, has been executed. And then the compiler will ensure that. In addition, we added to the ordered construct clauses. So the depend is the construct, the clause you use for the do across loops. All right, and that actually no longer takes a structured block. It's now a standalone. If you use the depend clause, the ordered construct is a standalone directive there. All right, and it just says that this point in my code is where you have to stop executing until the source of the dependence has been executed, and that takes care of it. Threads and SIMD now. Threads is the same as if you don't have anything, if you don't have any clauses, it's the same as it always was, and threads is a way to explicitly state that it's the ordered construct that's always been there. SIMD allows you to apply ordered to SIMD loops. All right, and so you can now say this part